Chance experiments with outcomes that are not equally likely. So example 1, when Jenna goes to the farmer's market, she usually buys bananas. The number of bananas she might buy and their probabilities are shown in the table below. So number of bananas, 0, probability is 0.1. Number of bananas for 2, probability is 0.1, and so on. So we're still given the table, and we need to say, what is the probability that Jenna buys exactly 3 bananas? Well, we refer to the table, and it's 0.2. Or 20%. Part B, what is the probability that Jenna does not buy any bananas? Now here, the probability that Jenna buys 0 bananas is 10%. Part C, what is the probability that Jenna buys more than 3 bananas? So the probability that Jenna buys 4 or 5 bananas is 0.2 plus 0.3. We add the two probabilities together and we find that it's 50%. So there's a 50% probability that Jenna buys 4 or 5 bananas. Part D, what is the probability that Jenna buys at least 3 bananas? Well, we're going to add up the probabilities for when Jenna buys 3, 4, or 5, and we find a grand total of 70%, or 0.7. What is the probability that Jenna doesn't buy exactly 3 bananas? Well, first we got to remember that the probability that an event does not happen is 1 minus the probability that the event does happen. So whenever the probability of the event that does happen, we subtract that from 1. So the probability that Jenna does not buy exactly 3 bananas is 1 minus the probability that she does buy exactly 3 bananas. So 1 minus 0.2, which equals 0.8, or 80%. So the probability that Jenna does not buy exactly 3 bananas is 80%. Important, and this is already in the notes, notice that the sum of the probabilities in the table is one whole. So 0.1 plus 0.1 plus 0.1 plus 0.2 plus 0.2 plus 0.3 equals 1. This is always true. When we add up the probabilities of all the possible outcomes, the result is always 1. So taking 1 and subtracting the probability of the event gives us the probability of something not occurring. Exercise 1. Jenna's husband, Rick, is concerned about his diet. On any given day, he eats 0, 1, 2, 3, or 4 servings of fruit and vegetables. The probabilities are given in the table below. On a given day, find the probability that Rick eats, part A, 2 servings of fruit and vegetables. Well, we observe the table. For when it's the number of servings of fruit and vegetables is 2, and the probability is 0.28, or 28%. For part B, on a given day, find the probability that Rick eats more than 2 servings of fruit and vegetables. Okay, so here we got 3, we got 4. We're going to add those two together, so 0.39 plus 0.12 equals 51%, or 0.51. For part C, on any given day, find the probability that Rick eats at least 2 servings of fruit and vegetables. So we're looking at these 3 being added together right here. So 0.28 plus 0.39 plus 0.12 equals a grand total of 0.79, or 79%. Find the probability that Rick does not eat exactly 2 servings of fruit and vegetables. So we're looking at this value. However, we want it when he does not eat exactly 2 servings of fruit and vegetables. So we're going to take 1 minus 0.28 and get 72%, or 0.72. For example 2, part A, find the probability that Lois receives 3 or 4 phone calls. So Lois works in an office and the phone rings occasionally. The possible number of phone calls he receives in an afternoon, and their probabilities are given in the table below. So find the probability when he receives 3 or 4 phone calls. Well, the probability that Lewis receives 3 or 4 phone calls is 1/3 plus 1/9. It's 1/3 for 3 phone calls, it's 1/9 for 4, so we add them together, get 4/9. Find the probability that Lewis receives fewer than 2 phone calls. Well, the probability that Lewis receives fewer than 2 phone calls is 1/6 plus 1/6 equals 2/6, or reduce it to 1/3. Part C, find the probability that Lewis receives 2 or fewer phone calls. The probability that Lewis receives 2 or fewer phone calls is 2/9 plus 1/6 plus 1/6 equals 4/18 plus 3/18. We're getting a common denominator here. If we were just to add those first 3 fractions, we would get a total of 5/9. But if we're getting common denominators, 4/18 is 2/9, 3/18 is 1/6, 3/18 is 1/6. We combine those 3 fractions, get 10/18, which simplifies to 5/9. Part D, find the probability that Lewis does not receive 4 phone calls. So here, we're taking the probability of getting the 4 phone calls, and we're subtracting that from 1. So 1 minus 1/9 equals 8/9. Exercise 3. When Jenna goes to the farmer's market, she also usually buys some broccoli. So the possible number of heads of broccoli that she buys and the probabilities are given in the table below. So the number of heads of broccoli and the probability for each one. So for number 3, find the probability that Jenna buys exactly 3 heads of broccoli. Well, it's 1/4. We look at the table and that value is given to us. Part B. Find the probability that Jenna does not buy exactly 3 heads of broccoli. So we take 1, we subtract 1/4 and get 3/4. So the probability that Jenna does not buy exactly 3 heads of broccoli is 3/4, or 75%. Find the probability that Jenna buys more than 1 head of broccoli. Well, we take 5/12, add 1/4, add 1/12, and we get 3/4. Find the probability that Jenna buys at least 3 heads of broccoli. So the values that we're looking at 3 and we're looking at 4 because we want at least 3 heads. So we're looking at 3 heads or 4 heads of broccoli. So 1/4 plus 1/12 and we get 1/3. For exercise 4, the diagram below shows a spinner designed like the face of a clock. The sectors of the spinner are colored red, R, blue, B, green, G, and yellow, Y. Writing your answers as fractions in lowest terms, find the probability that the pointer stops on the following colors. So for red, if we look at all the different sections here of this spinner, we would see that there are 1 for red, 2 for blue, 1, 2, 3, 4, 5 for green, and 4 for yellow. So if we were to find a grand total of all this, there are 12 sections. So for red, 1 out of 12. There's just one little sector for red, and there's 12 total sectors, so 1 out of 12. For blue, blue has 2 sectors, so 2 out of 12, which reduces to 1/6. For green, green has 5 sectors, so 5 over 12. Yellow, yellow has 4 sectors, 4 over 12, which can be simplified to 1/3. So the probability that the pointer stops on yellow is 1/3. So here we just got all the probabilities for each of those colors, so we're going to fill out the table. Red was 1/12, blue was 1/6, green was 5/12, and yellow was 1/3. Next, for exercise 6, still using the same spinner, find the probability that the pointer stops in either the blue region or the green region. So we're looking at the blue and the green combined. Well, we would add the 2 probabilities together. So using the table that we just created and filled out, we're going to add the two probabilities of blue and green. So 1/6 plus 5/12, we get 7/12. That's the probability of the pointer stopping on either blue or green. Find the probability that the pointer does not stop in the green region. So we want all the regions except the green region. So we're going to take 1 minus the 5/12 of green, which equals 7/12. So the probability that the pointer does not stop on green is 7/12. Thank you so much for listening in. If you have any questions, please do not hesitate to ask.